Well, good morning, or it's morning for me anyway. Welcome back. We are on week 4 of virtual learning in Algebra 1. Man, last week had some surprises, didn't it? I think most of us realized we weren't going to go back to the school building this year, but hearing the governor say that was difficult. I miss you all, and I miss our class. I miss our laughing and teasing and friendship and encouragement. I miss your smiles. I miss your questions. And I think you all miss each other. And this is hard, but it's keeping us safe. And our safety has to take priority for you to stay well and healthy, for your families to stay well and healthy, and for the people that you know to stay well and healthy. So that being said, we are going to continue looking at linear, quadratic, exponential this week. Today, we will do some examples, and then I will let you work on them. And then we'll have a Zoom on Tuesday, if you can make it. On Wednesday, we'll do a little bit more practice, and then have another Zoom Thursday, and then a quiz. So please make sure that you are staying up to date on our schedule. If you can't make it for some reason, I know that you have, sometimes you have conflicts with other classes, and I understand that. Just let me know, all right? Okay, we are in your pink book on page 57. If for some reason you don't have your pink book, I will attach this Word copy of these 2 pages that we're going to be working on. This is not new. This is what we worked on last week. On page 57, these are all equations. And so our job is to decide if it's linear, quadratic, exponential, or neither. And so let's think back just a few minutes what causes that. And if we know that it is x from an equation, we know that it is exponential. There are a couple of things, but from an equation, the big giveaway is that x is the exponent. That's the big giveaway, to know that it's an exponential function, right? X is the exponent. All right. How do you know if it's quadratic from an equation? Well, x is squared. The exponent, the largest exponent is a 2, right? X is not in the denominator, but x is squared. It looks like sometimes looks like our standard form, ax squared plus bx plus c. Sometimes it's in vertex form, a parentheses x minus h squared plus k, when we know the vertex. Sometimes maybe it's in a different form, but the big giveaway is that x has a 2, or the exponent is squared, and that's how we know it's quadratic. Again, how do we know it's exponential? If x is the exponent on a base. How do we know if it's quadratic if x is squared? How do we know if it's linear? There is no visible exponent. So you might see y equals 4, you might see y equals 4x, you might see y equals 4x plus 3. So you might see y equals 4, that would be a horizontal constant. You might see y equals 4x, you might see y equals 4x plus 3, but what? You have an understood exponent of 1 on the variable. And again, it's not in the denominator. It's not under a square root sign. It looks like a linear function that we've been looking at since September. Y equals mx plus b, y equals x, y equals a constant, right? Maybe it's in point slope form, maybe it's in standard form, ax plus by equals c, but it has a understood exponent of 1 on the variable. Quadratic has an exponent of 2. Exponential, x is the exponent. Well, what if it's not any of those? Well, then it's not any of those functions. So let's go in and look at some of these examples. The ones that we don't do, you can do on your own. So here's the first one, y equals 2x minus 3. What's our strategy? We're going to zoom in on where x is. Well, where's x? Right here. Okay, so let's see. Is x the exponent? 2x. No, x isn't the exponent. It's 2 times x. It's not 2 to the x power. All right, so x isn't the exponent. It's not exponential. Go to the next one. Is x being squared? No. Okay, if x isn't being squared, it's not quadratic. Could this be linear? Is this y equals a number? No. Is it y equals mx? Well, sort of. Is it y equals mx plus b? Yeah, right. Is there an understood 1 up here on our variable? Yeah, there is. And so what does that mean? That means that this is a linear function. If we graphed it, its graph would be a line. It would have a slope of 2 and a y-intercept of -3. Okay. Let's go to the next one. Is it exponential, quadratic, or linear? Or neither? Is it not any of those? Well, let's look. Y equals x squared. Is x the exponent? No, x isn't the exponent. Okay, so what does that mean? Not exponential. Is x being squared? Y equals x squared. Y equals, hey, x is being squared. So what does that mean? That means it's a quadratic function. All right, so we can say this is quadratic. How do we know? Right here, x is squared. What would its graph look like? Its graph would look like a parabola, the U-shaped curve. Let's go to the third one, f of x. And remember, f of x is just a fancy way to say y. F of x equals 3 to the x. Okay, let's go through our list. Is x the exponent? Yeah, it is. Y equals 3 to the x. X is the exponent. Okay, don't go any further. Why? Because you found it, all right? No, x is not being squared. No, it's not y equals mx plus b. It's y equals 3 to the x power, which means what? It's an exponential function. So we can come right here and say exponential function. And how do we know? Because x is the exponent. What would its graph look like? Well, the base is greater than 1, so it's going to be exponential growth. It's going to be that J-shaped curve. Okay? We did the first 3 on this page. There are 1, 2, 3, 4, 5, 6, 7 more problems. So we looked at one that's exponential, we looked at one that's quadratic, we looked at one that's linear. Let's scroll down to the bottom of the page. If you want to press pause here to make sure you have this written down, that's fine. I'm going to scroll down to the bottom of the page and look at another one. F of x equals x plus 1. But what's around here? It's got these like walls on either side of the equation. That's different, isn't it? We haven't seen that before. So if we haven't seen it before, it very possibly could mean that it's not one of the functions that we know. All right, so let's go through our list. Is x in the exponent spot? No, x is not the exponent. Okay. Is x being squared? Well, let's look. I don't even know what these things are, but is x being squared? No, it's not. Okay, so x isn't the exponent. X isn't being squared. It kind of looks linear, except for these things. Okay, y'all, well, these things mean it's a completely different function. Okay, these things are called absolute value bars. And absolute value is not a line. In fact, its graph ends up being a V. Absolute value means how far a number is from zero. And that distance is always positive. So these things right here, and if you'll look, you see them down here, okay, make it a different type of function. They don't make it linear. They don't let it be linear. And if there was a square on it, they wouldn't let it be quadratic either. If there was an exponent with there was a base with an exponent, it wouldn't be able to be exponential because it has these bars on it, and they're called absolute value bars. So this is not exponential or quadratic or linear because of this thing and this thing. And this is called absolute value. So we're not going to focus on the fact that it's absolute value. We're just going to notice these bars, hint, hint, hint. We're going to notice these bars and realize that it's not any of the ones that we're studying. So we could say it is neither or neither function because it has that absolute value bars on it. All right. So in your question, is it linear, quadratic, exponential, or neither? We would say because of those absolute value bars that are pressing in, it's not either of those, or it's neither of those. It's not exponential, quadratic, or linear. So again, this is a reminder of how to determine from an equation if it's exponential, quadratic, or linear, or neither. And this one happens to be neither. All right, see you in a few.